Welcome to our video on conditional probability and the multiplication rule. The probability of an event, we'll call it A, occurring when it's known that B, another event, has already occurred is called the conditional probability. So if we know something's already occurred and we're trying to work out the probability of a second event also occurring. The way we write the probability of A occurring when we know that B has already occurred is the probability of A slash B. Now the slash here, it's a straight up and down slash, and we read this symbol, straight up and down slash, as given. So this would read as probability of A given B. I've written that here for you. This slash, I'm calling it a slash. It's not really a slash though. It's not a backslash. It's not a forward slash. It's not a number 1 or a letter I. It's taller than the letters that you're writing and longer at the bottom, and it's straight up and down. In fact, I'm going to rewrite this one because I think it's slightly at an angle, and I'm a bit of a perfectionist like that. Straight up and down. You'll find it on your computer keyboard above the backslash, this one. If you press shift and this one, you'll get a straight up and down line. So it's the probability of A given B. This is what's called conditional probability. It's conditional, B is conditional on A occurring. An example of where we would use that. When you roll a fair die and event A is rolling a 4, event B is rolling an even number, what's the probability of rolling a 4 given, there's that given word, probability of rolling a 4 given you have rolled an even number. So we're looking for the probability of A, which is rolling a 4, given probability of B, which is rolling an even number. A probability of event A occurring given we know B has occurred. Let's have a look at how those two things would look in a Venn diagram. I've got one drawn here. I'm going to add in my universal set in the corner. And we're rolling a dice. A is rolling a 4. B is rolling an even number, so it's going to be 2, a 4, or a 6. And you can see A is a subset of B. These conditional probabilities work when one event is a subset of another event. So A is a subset of B. B includes everything inside the red, which is 2, 6, and 4, all the even numbers. All the other numbers go in the universal set, 1, 3, and 5. So we should have 1, 2, 3, 4, 5, 6. We've got all of them there. Those are all the possible outcomes when we roll a dice. So the probability of A given B is going to be just like we've always looked at. The number of favourable outcomes. So that's the number of 4s that are an even number of even numbers that are a 4 over the total number of outcomes. In this example, the total number is just talking about the red, it's just talking about B. And we've got 1 which is in A, well, one which is in A and B, and 3 altogether in B. So the number of favourable outcomes is 1, that's this one, and the total number of outcomes in B is 3. So the chance of getting a 4, given you've rolled an even number, is 1/3. Here's some general formulas we can use for conditional probability. The probability of A given B is equal to the probability of A intercept B over the probability of B, which is what we just used up here. We didn't have an intersection, but it's where it intersects. Of course, if we're using this, we need to make sure that the probability of B does not equal 0. It has to equal some positive number. Otherwise, you're dividing by 0 and the formula won't work. We can rearrange this general formula for conditional probability to find the multiplication rule. And all we do is multiply both sides by probability of B, and we get the probability of A intercept B is equal to probability of A given B times the probability of B. Now, when you are doing conditional probability, you really need to make sure that you do things in the right order. So just going back to some of our earlier work, you'll remember that probability of A intercept B is exactly the same as the probability of B intercept A. Doesn't matter which order you say put A and B in. But when we're doing conditional probability, the probability of A given B is not equal to the probability of B given A. They will be different amounts, so make sure you don't get tripped up by that. Let's look at an example. For 2 events, the probability of A is 0.35 and the probability of B is 0.45. The probability of A given B is 0.4. Find the probability of A intercept B and the probability of B intercept A. I've put some steps down here when you are following one of these problems. The first thing you need to do is write down all the information you have using your mathematics language. Often this will be in a worded problem and you'll need to write it out in proper maths language. So we've got probability of A equals 0.35, probability of B equals 0.45, and probability of A given B is 0.4. Second step, write down the formula that we are going to use. We're going to use this one because we're trying to find A intercept B. Probability of A intercept B equals the probability of A given B times the probability of B, which is 0.4 times 0.45, which equals 0.18. So probability of A intercept B is 0.18. Part B is asking us to find probability of B given A. Remember, B given A is different to A given B, so we can't just write down it's 0.4. We'll need to do a bit of working out first. Let's start with the formula we're going to use, which would be this one, but we're going to have B and A swapped around, which is okay because it means, well, it doesn't really matter for the intersection one, but we'll have probability of A on the bottom because it's always this second event here that goes on the denominator. Probability of B given A equals the probability of B intercept A over the probability of A, which equals probability of A intercept B over the probability of A, which equals 0.18, this is from up here, over 0.35, and it equals 0.51. Thanks for watching the video.